Hey everybody, it's Dynamic Math here. We're going to investigate what an altitude of a triangle here is here in this activity. So notice in the applet above you have a triangle there whose vertices are movable. So move those vertices anywhere you would like and then slide that slider slowly. Now, and as you do, you will see an altitude being formed. Now, there it is. It's drawn in purple. But let's hit rewind and let's actually kind of bring the vertex over a little bit. We'll just move them around again and just slide to illustrate one more time. So it looks like that purple altitude originates or starts being drawn from the vertex of the triangle, or one of the triangle's vertices, right? So therefore, we're drawing that purple segment from the vertex to, I see a right angle there. So how would you put this into words? It's kind of tricky, right? I mean, here's the altitude here. Well, the altitude is it's a segment, right? That purple highlighted segment right there. It connects a vertex to, well, not so much the opposite side. I mean, if you notice here, this perpendicular doesn't even meet that side right there. I mean, a lot of students like to call the bottom of the triangle the base, but you really can't refer to the base as the bottom of a triangle. I mean, what if I were to flip this and like kind of turn this around and turn it over, right? Where's the base now? I mean, any side of the triangle could be a base, but let's not get too confusing here. But let's go back and actually try to figure out what an altitude is, right? An altitude is actually a segment that connects one vertex not to the other side of the triangle, not to the opposite side, but to the line containing the opposite side of that vertex. Again, an altitude of a triangle is a segment, the purple segment here, that starts from a vertex that is drawn perpendicular here to the line containing the side of the triangle opposite that vertex. And the side opposite this blue vertex is this segment I'm kind of tracing out with my arrow right here. So again, notice here the altitude lies outside the triangle. And sometimes the altitude of a triangle can definitely lie inside of it. The length of the altitude is called the triangle's height, right? But is it ever possible for the altitude to be a side of the triangle? And to answer that question, I would have to say, well, yes. I mean, look at that. What kind of triangle do we have here? That's right, it's a right triangle. So in a right triangle, one of the legs, in fact, either leg could serve as an altitude. In this case, the altitude lies inside the triangle, and in a case like this, the altitude lies outside the triangle. Again, an altitude of a triangle is a segment that connects any vertex to the line containing the side opposite that vertex in such a way that that segment meets that line at a right angle. And that's what an altitude of a triangle is. And since a triangle has three vertices, how many altitudes can a triangle possibly have? Yep, you got it, 3. And you're also going to investigate a very cool property about the lines containing the 3 altitudes of a triangle in some of the investigations to come. So there you have it, an altitude of a triangle. Thanks for watching.